Next, we'll do some examples to apply this result in the table given above. Example 1, find the general solution to the differential equation. So this one is in fact y double prime minus 6y prime plus y is equal to 0. In order to solve this equation, or in general any second order homogeneous differential equation, you need to be able to write down the characteristic equation to start with. So for this one, the characteristic equation will be 9 lambda squared minus 6 lambda plus 1 is equal to 0. And next, we'll solve this we'll solve this quadratic equation. So lambda is equal to, we'll just use the formula. Negative b in this case will be 6 plus or minus root b squared, which is 36, minus 4ac, which will be 4 times 9 times 1, which is also 36, divided by 2a. So what we have? We have lambda is equal to, in fact, this term will become 0. So it's 6 divided by 18, which is 1 over 3. And in fact, which case we're dealing with now? Both lambda values are the same. That means we are really dealing with case 2. And according to the result in case 2, the general solution should be y equal to e to the power of lambda x times ax plus b. So the solution is, which is e to the power of lambda value is a third, so I put a third here, times ax plus b. And we're done. Okay, that's for example 1. So this is in fact, this method works for all homogeneous second order differential equation. First step, you write down the characteristic equation. Second step, you solve the values for lambda. Third step, you find out which case we're dealing with, and then you can just use result given in the table. Let's move on to the next example. Okay, again, let me rewrite this equation in a simpler form. Find the general solution to the differential equation 2y double prime plus 5y prime plus 6y is equal to 0. So what is the characteristic equation? It's going to be 2 lambda squared plus 5 lambda plus 6 is equal to 0. And the solution is going to be lambda equal to negative b, which is negative 5, plus or minus root b squared, 25, minus 4ac. So it's 4 times 2 times 6, which is 48, divided by 2a, which is negative 5 plus or minus root negative 23 divided by 4. Let's pause for a second. So this corresponds to which case? Let's go back to the table for a second. Well, apparently we're dealing with case 3 when b squared minus 4ac is less than 0, because we get negative 23. Okay, so now in this case, we have to write down the value of lambda in this form, alpha plus or minus beta j. You may wonder, where does this j come from? Well, let's rewrite this in a slightly different way. Before I do anything, I need to remind you that j squared is equal to negative 1, which is a unique complex number. And this actually tells us j is in fact root negative 1. So you need to know this fact in order to write this lambda value in alpha plus beta j form. So if we know j is equal to root negative 1 and root negative 23 in our example is really root negative 1 times root 23, which is root 23 times j. This is how this complex number j shows up. Oops. Okay, so let's continue. So now I have negative 5 plus or minus root 23j divided by 4, which is, now let's separate the real part and the imaginary part. Negative 5 over 4 plus or minus root 23 over 4 times j. So this is the alpha plus or minus beta j form. And we know the value for alpha, it should be negative 5 over 4, the value for beta, which is root 23 over 4. Once we know these two values, the general solution can be written in this way, according to the table. Okay? That's for example 2. Can you finish up this example by yourself?